Hello everyone, welcome to Numeric Ninja. Today we are going to solve a problem that is taken from IMO 1968 as follows. Find all natural numbers n such that the product of digits of n is same as n square minus 10n minus 22. Now in this problem, I am going to denote the product of digits of n as p of n. Now, to proceed further in this problem, we are going to first derive a claim. So I'm claiming that if P of n denotes the product of digits of n, then P of n must be less than n. Now let's see the proof of the claim. Now, to write the proof of the claim, we are going to use the decimal expression of n. I'm going to write the n as a1, a2, a3 up to ak as its decimal expression where ai's are digits. Now, what do I mean by decimal expression? Now, let's take up an example. If n is equal to 231 in this case, then we can compare that ak is equal to 1, a3 is, not a3, ak minus 1 must be equal to 3, and a k minus 2 is equal to 2, and the rest ai's are all 0. If I take up the example n equals to 231. Now let's elaborate this example. Now note that in this example, we can also write n as 2 into 10 square plus 3 into 10 to the power 1 plus 1 into 10 to the power 0. Now similarly, we can say that if n has this decimal expression, then n must be written as 10 to the power n k minus 1 times a1 plus 10 to the power k minus 2 times a2 plus 10 to the power k minus 3 times a3, and this will go up to 10 to the power 0 times ak. So this is the expansion of n, and this is a decimal expression of n. Now, if n has this decimal expression, then we can say that the product of digits of n is same as a1, a2, a3 up to ak. Now, if we separate out a1 and just write down a2, a3 up to ak, then we know that since ai's are all digits, then ai must be lie between 0 and 9. So we can say that all a2 is less than 9, a3 is less than 9, up to ak is also less than 9. So if we multiply these terms, we get that a2 times a3 up to ak is less than 9 times 9 times 9. And now, since we are multiplying k minus 1 many terms here, so we can say that we are multiplying 9 actually k minus 1 many times. So this is actually same as 9 to the power k minus 1. So we can say that a1, a2, a3 up to ak when multiplied is less than 9 to the power k minus 1, and 9 to the power k minus 1 is strictly less than 10 to the power k minus 1. Since 9 is less than 10, we can just raise both sides by k minus 1, and we get that 9 to the power k minus 1 is less than 10 to the power k minus 1. So we get a very interesting fact that a2, a3 up to ak is less than equal to 9 to the power k minus 1, and this is less than 10 to the power k minus 1. So if you multiply a1 to both the side of the inequalities, we get a1, a2, a3 up to ak is less than 9 to the power k minus 1 times a1 less than 10 to the power k minus 1 times a1. Now, this is actually the product of digits of n. So we can say that the product of digits of n is strictly less than 10 to the power k minus 1 times a1. Now remember the decimal expression of n that we had derived over here. So we have expanded n in this form. Now let's take a look in that expanded form of n. It's same as writing 10 to the power k minus 1 times a1 plus 10 to the power k minus 2 times a2 up to 10 to the power 0 times a0. Now, since all the AIs are greater than equal to 0, we can say that the expression is greater than equal to 10 to the power k minus 1 times A1 plus 10 to the power k minus 2 times 0 plus 10 to the power k minus 3 times 0 up to 10 to the power 0 times 0. So this is actually equal to 10 to the power k minus 1 times E1. So we get that n is greater than equal to 10 to the power k minus 1 times E1. And we already know from here that 10 to the power k minus 1 times A1 is strictly greater than the product of the digits of n. So hence we have proved that n is greater than the product of digits of n. This is a very important lemma that we are going to use in this problem. Now let's go back to the problem. Now remember that since n square minus 10n minus 22 is the product of digits, hence it must also be positive. And if n square minus 10n minus 22 has to be positive, we can say that n into n minus 10 must be greater than 22. And since n is just a natural number, we can say that n must be greater than equal to 12. If n is less than 10, then this expression will be negative and the whole expression will become less than 0, and which cannot be. But if this expression is also 11, if n is 11, then this n minus 10 will become 1. So we can say that will become actually 11 times 1, that is 11. This will not be greater than 22. If n is equal to 12, then this expression will become 2 and n is 12. So the product will become 24, and hence we can say that yes, this is greater than 22. So this will only happen if n is greater than equal to 12, if n is a natural number. If n is not a natural number, we can simply found it by doing some quadratic stuff, but we are not going to do because we are only dealing with natural numbers for easier calculations. Now let's put the value of p of n in this expression and see what happens. It's n square minus 10n minus 22. So we can say that 22 is greater than n square minus 11n, and that is same as writing n into n minus 11. Now if we check it, this is only satisfied by those natural numbers which are less than equal to 12. If we take up 13 as n equals to 13, then n minus 11 becomes 2, and 13 into 2 becomes 26, and 22 is not greater than 26. This is only true for n less than equal to 12. And if I take n less than equal to 12, then n minus 11 becomes 1 and n becomes 12. So 12 into 1 becomes 12. So if n is a natural number, the only set of natural numbers that satisfy the inequation that n square minus 11n minus 22 is less than 0 is n is less than equal to 12. But remember, we have just now shown that n must be greater than equal to 12 by the fact that the product of digits of n is greater than 0. So hence we can say the only natural number that satisfies these two inequalities are n is equal to 12. So n is equal to 12 is the only natural number that satisfies both this inequality, and hence n is equal to 12 is the only answer. I hope that you liked the video. If you did, please give us a thumbs up. Please subscribe to my channel. Feel free to suggest any other alternative solution in the comment section. See you in the next video.